Assalamualaikum warahmatullahi and good morning. Okay, I am Madam Nur Aidah binti Sobri. So for today, our session for program Lepton and Meka, we will discuss chapter 7, which is the rotational of rigid body. Okay, so before we go further, let's look at the list of formula for this chapter. So ini ada beberapa list formula yang you should be familiar for this chapter. Okay, so kita ada S equal to R theta. So S is the linear displacement. So theta is the angular displacement. Okay, next we have V equal to R omega, where V is the linear velocity, omega is the rotational or angular velocity. So we can relate the linear and the rotational motion by using V equal to R omega, S equal to R theta, and A equal to R alpha. Okay, so A is the linear acceleration yang biasa kita guna. So alpha is the angular acceleration. And the number 4 is the AC equal to R omega square, which is also equal to V square over R. So AC dengan AT ni tak sama. So AT ni linear acceleration, where AC is the centripetal acceleration, where the direction of AC always towards center of circle. Dia cuma melibatkan rotational motion. Okay, next kita ada 1 revolution equal to 2 pi radian. Now then we have another 3 equation for rotational kinematic. First is W equal to omega equal to omega naught plus alpha t. So omega here represent final angular velocity. Omega naught is the initial angular velocity, plus with alpha is angular acceleration, then time with t. So kalau you all perasan, sebenarnya dia lebih kurang sama dengan equation for the linear kinematic, which is we have V equal to U plus AT. Okay, second equation, theta equal to omega naught t plus half alpha t. So ni kalau kita nak analogi from the linear kinematic, kita ambil kira daripada S equal to ut plus half at square. And equation number 3, omega square plus omega naught square plus 2 alpha theta. Equation ni pula we get it from V square equal to U square plus 2 AS. Okay, so yang V ini kita analogikan dia sama dengan omega, U is omega naught, A is alpha, T samalah, sama ada linear ataupun rotational motion, T tu still lagi sama. Okay, now we look at the first question. So untuk hari ini kita akan discuss 3 question. Look at first question. So we have a wheel start from rest and accelerate uniformly. As the rate of rotation changes from 10 rpm to 50 rpm, the wheel make 50 revolution. Okay, so now the question is dia nak calculate the angular acceleration and number of revolution completed by the time the wheel reaches 10 rpm. So first, bila kita dapat soalan, make sure we take out all the information given. So tengok sini dia bagi tahu from rest, so meaning omega kita, omega naught sini 0. Dia ada 3 condition. So let's say this is the starting point. Starting point ini omega, kita label as omega naught, which is equal to 0. Tu dia jalan sampai dekat sini, omega dia become 10 rpm. So please remember, always remember the SI unit for the omega is radian per second, but given in the question is rpm, which is rpm to stand for the revolution per minute. So dia jalan lagi. So at this point omega dia become 50 rpm. So meaning now kita ada 3 point. So refer to our reference point, which one is initial, which one is the final. Okay, now lagi information given. Dia bagi here is 50 revolution. Actually here is the value of theta, but the unit given is in revolution. Okay, kita tengok question. Okay, question E. Calculate the angular acceleration. So we take out the information. We have omega naught, which is, kalau refer kepada diagram kita tadi, kita punya simple sketch tadi. So kita ada 3 point, 1, 2, 3. So dekat sini omega dia 0, dekat sini omega dia 10 rpm, and here is omega become 50 rpm. So now our reference is omega 10 rpm here as our initial. Final kita, so point kita 2 ni 1, 2. So final kita 50. And tengok lagi, kita ada, so theta given is 50 revolution, we change the unit to radian. So by times 2 pi, because 1 revolution equal to 2 pi, and we get 314.16 radian. Next we have omega naught. Omega naught is 10 rpm, changing the unit to radian per second. So R here stand for revolution. So bila revolution kita nak tukar kepada radian, we have to time 2 pi, nak tukar kepada radian kan. So then over 60, because ini refer kepada minute. So 1 minute equal to 60 second, and we get omega naught 1.047 radian per second. Number 3 is the value of omega. The same step with the omega naught, kita tukar unit dia, and we get 5.236 radian per second. Next. Okay, so now we have theta, omega naught, and omega. So question asks to find the angular acceleration, which is angular acceleration is alpha. So theta dah ada, omega and omega naught. So we just substitute the value, and we get alpha equal to 0.042 radian second negative 2. Okay, next question B. Number of revolution completed by the time when the wheel reach 10 rpm. So from 0 to 10 rpm, so how many revolution? So now how many revolution? Number of revolution refer to the theta, angular displacement. So now kita refer from the initial. So tadi kita ada 3 point, so kita akan refer omega 0. Sini omega yang last tadi 50 rpm. So here is omega 10 rpm. So now reference point kita dekat sini. So initial kita 10 rpm, initial kita 0, and final is 10 rpm. So by using equation theta equal to omega square minus omega naught square over 2 alpha, which is ini sebenarnya kita dapat from omega square equal to omega naught square plus 2 alpha theta. Nah, okay, kita nak cari theta. Omega square kita dah ada, omega naught pun dah ada. Same goes to the alpha. So and we get theta is 13.05 radian. Okay, now look at the question. The question asks to find the number of revolution, but theta yang kita dapat tu in radian. So apa nak buat? Kita kena tukar unit dia from radian to the revolution. So we just divide by 2 pi because of 1 revolution equal to 2 pi radian, and we get 2.08 revolution as the number of revolution dia. Okay, so settle question number 1. Kita sambung question number 2. So we rotating about a fixed axis at 0.83 rps is uniformly accelerated for 40 seconds and makes 40 revolution. So T 40 second, theta 40 revolution. Here is the value of omega. So omega dia RPS. RPS stand for revolution per second. So kena tukar to the radian per second. Question A, kita nak find the angular velocity at the end of this interval. Omega final. And question second, extra time required for the speed to reach 80 revolution per minute. Let's tengok A dulu. So we want to find angular velocity omega final. So we have omega naught 0.83 rps. Change the unit of omega by times 2 pi, and we get omega naught 5.215 radian per second. Okay, next apa lagi kita ada? We have theta, dan revolution pun kena tukar kepada radian. So kenapa kena tukar? But SI unit is radian for theta. Untuk omega SI unit dia radian per second. So theta dia kita dapat 251.3 radian. Lagi. So kita nak find angular velocity. We have theta, we have omega naught, we have t. Then we are going to find omega. Tapi kita tak ada alpha. So meaning we have to find the alpha first. So by using the equation theta equal to omega naught t plus half alpha t square, kita substitute all the value and we get alpha is 0.053 radian second negative 2. Tapi objektif kita nak cari angular velocity. So apa nak buat? We are using another equation. Omega equal to omega naught plus alpha t. So omega kita 5.215 plus if alpha our angular acceleration 0.053 radian second negative 2. Next kita ada juga value of t dia, t is 40, and then we get omega final 7.34 radian second negative 1. Okay, we go to question B. Extra time required. So for the speed to reach 80 revolution per minute, so extra time berapa lama lagi supaya dia boleh reach 80 revolution per minute. Okay, ini pun ni final dia, kita dapat 80 revolution per minute. Apa nak buat? Tukar lagi unit dia. Tukar unit dia, kita dapat 8.378 radian per second. So kita nak cari t dia dulu. So cari t dia. So sebenarnya sekarang ni kalau perasan omega ini kita guna 7.34. Yang previous sebelum ni kita dapat 7.34. So omega 2 is 8.378 minus 7.34 over alpha or angular acceleration. Sebab dia kata constant acceleration, so kita guna alpha yang sama. and we get T equal to 19.58 second. Okay, kita continue. Our third question is, actually this is the real past year question, PSPM session 2011-2012. So, a granny wheel in the form of a solid disc has a mass of 1.5 kg with radius 0.1 and moment of inertia 7.5 exponent negative 3 kg meter square. So, the wheel is rotated by a constant torque from rest to the final angular velocity 1200 revolution per minute in 2.5 seconds. So first question, they should calculate the final angular velocity in radian per second. So actually the value of final angular velocity given in the question, but unit dia revolution per minute. Question dia nak the final angular velocity in radian per second. Okay, next, calculate the angular acceleration, and the last one, calculate the number of revolution in 2.5 seconds. We go to the first one, calculate the final angular velocity. We just change the unit. So info given, we have m, mass, radius, I, moment of inertia, omega known, and omega final. So omega final 1200 rpm, revolution per minute nak tukar kepada radian per second. So nak tukar 1200 revolution per minute, we time with the 2 pi radian over 1 revolution, because 1 revolution equal to 2 pi radian. So kita boleh cancel. So per minute, so minute hilang sini, sini pun cancel, because 1 minute equal to 60 second, and we get omega final is 125.67 radian per second. Next, to calculate the final angular acceleration in radian per second. Okay. Angular acceleration in radian second negative 2. So nak cari itu pula. So we have the value of omega, also omega naught, which is omega naught kita 0, by going to find alpha or angular acceleration. So T dia in 2.5 second, we just substitute the value into the equation, and we get alpha equal to 50.27 radian second negative 2. Okay, let's look at our last question. Calculate the number of revolution in 2.5 second. Number of revolution. So dekat sini kita nak find theta, tapi unit dia dalam revolution. So theta equal to omega naught t plus half alpha t square. So kita dah ada omega naught here is 0, T 2.5, alpha is 50.27, and we get theta 157.09 radian. Soalan dia nak number of revolution, so kena tukar unit dia. Therefore the number of revolution equal to 157.09 radian time with 1 revolution over 2 pi radian, because 1 revolution equal to 2 pi radian. So kita dapat berapa ni? Okay, so the answer is 25 revolutions. Okay, so that's all 3 questions we have discussed in Lepton and Meka session for this week. So good luck for you. Thank you for joining our program. Thank you. Assalamualaikum.